So this is chapter 4. This is our final chapter of the manual. We have 8 best management practices for which we provide design guidance. Amending construction site soils, dispersion, bioretention, trees, permeable pavement, vegetated roofs, minimal excavation foundation, and rainwater harvesting. The LID BMP design guidance that we provide in the manual is based on a culmination of a few different sources. Other LID guidance manuals, for example, we pulled from the Yakima Regional LID Stormwater Design Manual and from the LID Technical Guidance Manual for Puget Sound. We also pull extensively from Ecology's Stormwater Management Manual for Eastern Washington. We make sure we're compatible with that manual, and we also draw specific guidance from that manual. We've also pulled in research from academic institutions. The Technical Resource Committee, Strategic Advisory Group, and the Consultant Design Team experience is also reflected in the manual. So organization of the LID BMP design guidance, each BMP chapter is organized with the same structure, and that structure includes a description of the BMP, discussion of applications and limitations, design guidance, sizing guidance, and/or guidance on how to adjust your hydrologic model to account for credits associated with these facilities. We list infeasibility criteria for each BMP, which is largely adopted from the Western Washington Stormwater Management Manual, but made relevant to Eastern Washington. We also discuss construction and maintenance, and then we also have an appendix on maintenance that goes into quite a bit more detail than you'll find in Chapter 4. And so the purpose of this training is really to inform you of the contents of the manual, but not to provide very detailed training on design of the individual BMPs. So we're just going to cover pretty briefly what's contained in the manual for each BMP. So as I mentioned, maintenance guidelines are provided for each of the LID BMPs in Chapter 4, but Appendix D also provides typical maintenance goals and objectives, types of maintenance agreements and training, and then matrices that spell out the types of maintenance activities and schedule of those activities. 5 BMPs: bioretention, amended construction site soils, permeable pavement, vegetated roofs, and rainwater harvesting. So the first BMP is amending construction site soils, and I'll just run through some of the applications and limitations that we have included in the manual. Amending construction site soils can help you improve your soil structure, porosity, and reduce bulk density. Can help increase infiltration, increase moisture holding capacity, cationic exchange capacity, which helps you with pollutant absorption and filtration. Can help buffer the soil pH, improve plant growth, disease resistance and aesthetics, and reduce pesticides and peak season irrigation, meaning that it can help you hold moisture on your site more effectively and reduce irrigation demands. And then dispersion, summarize the discussion of applications and limitations in the manual. A minimum 10-foot flow path will be required for dispersion BMPs, or would be recommended, I should say. Can be used for a variety of impervious surfaces, for walkways, driveways, roofs, etc. So this is a very versatile BMP where you have that space available for that dispersion length, which can be tough on a tight site. It's also suitable for public and private projects, and can help meet landscape requirements if it's designed with appropriate vegetative cover. So there's a lot of opportunities there with dispersion if your site would allow for that, meaning if you've got space. Types would include concentrated flow dispersion, sheet flow dispersion, and full dispersion. All of these are discussed in the manual. Bioretention is one that does get a lot of attention in the manual. Bioretention and permeable pavement both receive a lot of attention in the manual. Bioretention is applicable to many geology types and climates, including, of course, semi-arid and cold climates like we have in Eastern Washington. Bioretention can also be well utilized for public and private property projects, and can be integrated with site landscaping. It's a very big benefit of bioretention. The manual provides design guidance for bioretention cells, bioretention swales, and infiltration planters, which would have vertical walls typically, could be made of concrete or another type of material. But infiltration planters are similar to bioretention, except their geometry is a little different. Trees. Len provided a lot of discussion on trees, but trees are also considered an LID BMP. As Len mentioned, evergreen trees provide greater stormwater benefit than deciduous. To have a tree that really performs duty as a stormwater management facility, it requires adequate soil volume and quality to allow that tree to reach its healthy size. And trees need to be protected near snow plowing or snow storage areas. Optional considerations for trees: soil cell systems, for example, the Silvacell would be one example of this, would allow you to suspend the pavement over the tree roots and provide a really high volume of soil to promote large trees on your site. So that would be a way to really optimize the space available in your right-of-way, for example, to allow for everything that's required in the right-of-way, your travel lane widths, sidewalks, and everything else, but yet get really large, healthy trees in there that provide a stormwater benefit. Structural soil is another method that can help you promote large, healthy trees in a really constrained environment with a lot of impervious area. So we do provide guidance in this manual for design of permeable pavement, considering freezing and snow accumulation and snow removal. Underdrains and/or liners can be used in non-infiltratable areas. So if you did want to use permeable pavement for storage rather than for infiltration, or for water quality treatment for whatever benefits it might provide there, you can use permeable pavement in areas with poor infiltration. There's other benefits there. There is a successful track record of using permeable pavement in cold weather climates, for example, Chicago, New Hampshire, Minnesota, Michigan, New York. It has been done before, and it's been shown to work. The manual offers design guidance on porous asphalt, pervious concrete, permeable interlocking concrete pavements, and grid systems. Vegetated roofs. One of the limitations associated with vegetated roofs is that they can be expensive. Of course, that depends on your site design. They're not really readily used for retrofit in most applications. It's easier to use a vegetated roof for a new development project. Special consideration for freezing, heat, and wind needs to be factored into the design. Use in residential projects may be a little bit more limited than commercial projects. There again, it really does depend on your design. You can include roof terraces where some portions of your terraces are vegetated and others are not, or portions of your roof could be designed to drain into a lower terrace that's vegetated. That would be a really effective way of doing that. And this technology is still very much evolving. There's two types of vegetated roofs that we provide design guidance for in the manual. There's extensive, which means that there's less than a 6-inch growing media, which means that you typically can't support trees or larger vegetation. And then there's intensive, where you have greater than or equal to 6 inches of growing media, and that would allow you to provide a wider variety of plants, shrubs, trees, but of course your structural design would need to account for those higher loads. Minimal excavation foundations. These can be used on residential or commercial structures up to 3 stories high. Good application for accessory structures, for example, porches and decks. High groundwater or high organic soils are typically considered to be problematic. They can be used in a variety of different soil types, though: hydrologic soil groups A, B, C, and D, and in fill soils with appropriate piles and connections included in the design. So where some of your other BMPs may be limited based on soil type, this one is less limited based on soil type. You receive your highest flow control credits, meaning we expect the hydrologic benefits of these types of BMPs to be greatest when the roof runoff is dispersed on the upgradient side of the structure in accordance with Ecology's BMP F6.41 in the 2004 Stormwater Management Manual for Eastern Washington. And the last BMP that we've included in the manual is rainwater harvesting. So rainwater harvesting has a good application on residential and commercial projects with high irrigation or non-potable water demands. So using these cisterns to store water can help you offset those irrigation or non-potable water demands for outdoor use. Can also be used to supply indoor use to help offset water demand inside the building. Orifice-controlled cisterns can also help reduce combined sewer overflows as well as localized flooding. So this is a very versatile BMP that can be used to meet a lot of different types of design goals. It's completely independent of soil type or infiltration capacity of your site, as was the vegetated roofs. I should have mentioned that there. So very important part of the toolbox. Chapter 4 is the last chapter in the manual. Then we have a pretty extensive body of appendices. Appendix A is a glossary. Appendix B provides detailed guidance on evaluating soil infiltration rates using a couple of different methods, including small pilot infiltration test method, large pilot infiltration test method, and then some other methods. Appendix C is sizing of LID facilities, and we're going to demonstrate possible ways of sizing LID facilities in the afternoon. Appendix D provides a plant list. Appendix E provides detailed drawings. F will provide a planning and design checklist, similar to what we're going to use to facilitate our afternoon exercise. Appendix G provides detailed guidelines for maintaining LID facilities. And Appendix H is references. So to give you a sneak peek of some of the information in these appendices, this is from Appendix E, the detailed drawings. This one is bioretention without an underdrain. Another example that's provided in the manual, bioretention in a typical roadway section, to show you how you can accommodate the whole right-of-way cross section and integrate LID BMP while still meeting your transportation requirements. Permeable pavement, we provide a detail that can be adopted by jurisdictions or used by designers as appropriate. And here's an example of the type of information provided in the maintenance appendix, which again is Appendix G. And this particular table was pulled from the bioretention section. Each section we provide guidance on routine and non-routine maintenance. And so as an example for bioretention, routine maintenance, watering, cleaning curb cuts, removing and or pruning vegetation, weeding, mulching, removing trash. These are considered routine maintenance activities. Then we list the objectives, then we list the schedule. So watering twice annually, May and July, or as indicated by plant health, and then we provide additional notes. So this is the type of maintenance information that's provided in the appendix. Non-routine maintenance, just to give you an idea of what's in the manual. Some of the non-routine maintenance activities for bioretention would include maintain access to infrastructure, which could include clearing vegetation within a foot of inlets and outfalls, maintaining access pathways, sediment removal, shoveling or raking out sediment, cleaning the underdrains with a jet or rotary cleaning device, clean intersection of pavement and vegetation, replace vegetation, replace soil. Now, replacing soil is something that is definitely not expected to be routine. There's, some jurisdictions would expect to have to do that every 15 years, just as a planning level figure, but that's certainly not expected to be a routine activity. Rebuilding or reinforcing structures and regrading or recontouring the side slopes. So these are the types of activities that we provide guidance on for non-routine that you would do when the site shows you that this type of maintenance is needed, but you wouldn't have to perform it every year or every 2 years. How do we amend site soils such that we don't exacerbate TMDLs or other goals for a basin? And the answer is that you have to be very careful about the source of your organics and the quantity of your organics. I think that if you've got phosphorus levels that need to be achieved or nitrogen levels that need to be achieved, you just have to put a lot of thought into how much organic content, what's the source of that organic content, and design accordingly. There's no formula, there's no real formula for that. The question is, have we addressed the impacts of LID BMPs not being maintained? What I would say is we provide guidance on how to design, construct, and maintain the BMPs, but we don't provide guidance on what to do if no maintenance is going to occur. My response to that would be that it is up to the designer to design, sufficient redundancy, kind of as Lynn went through with the soft versus hard. Redundancy is important in any design, whether it's conventional or low-impact development. In maintenance, again, the designer needs to know the owner for whom they're designing, and they need to know what can be expected as far as how these facilities will be maintained. If you're designing for someone that you know is not going to maintain permeable pavement, then as a designer, it might be wise to have conversations with the owner and make sure that they're aware of what types of maintenance would need to be in place for the long term, and get an understanding up front that required maintenance will occur for the facility that you're designing. And I really feel that that's very similar to any kind of design process.